So real quick, before we start talking about division, I need to bring up the concept of reciprocals, okay? So what a reciprocal is two numbers whose products are said to be 1 are reciprocals. So for example, if I have the fraction 3/7, its reciprocal is 7/3 because if I multiply these together, I get 21 over 21, which is just 1. Typically what you do is flip the fraction, right? This is this fraction flipped in order to find the reciprocal. Now, friendly reminder, if I have a negative number, like negative 3/4, its reciprocal is also going to be negative because the product has to be a positive one. So the reciprocal of negative 3/4 reciprocal is negative 4/3. Now what about whole numbers? What if I had 7? What's the reciprocal of 7? Well, remember that 7 can be written as a fraction over 1. So the reciprocal of 7 over 1, I just flip it, is 1/7. So it's also important to note that every number has a reciprocal but 0, okay? 0 can't have a reciprocal because any number multiplied by 0 is 0, right? And reciprocals have to have a product of 1. And then here's what I'd mentioned on the previous slide about whole numbers and reciprocals of negative numbers. The main reason I've been bringing up reciprocals is to talk about division, okay? So when we're dividing fractions, when we divide a fraction by another fraction, we multiply by the reciprocal. So if I have two fractions, I keep the first fraction the same, and then I multiply by the reciprocal of the second fraction, right? I had CD, now I have DC, okay? And that's going to tell us the quotient of these two fractions. So we have a faster way to remember them multiplied by the reciprocal, and I call this keep, change, flip. We keep the first fraction the same, we change from multiplication to division, and we flip the second fraction. So we keep, change, flip. I really wish this was like KFC. I think that'd be a lot easier to remember, but math didn't work out that way. So let's work through an example. If I have 2/3 divided by 5/8, I keep the first fraction the same, I change from division to multiplication, and I flip the second fraction. So instead of having 5/8, I have 8/5. Then I go ahead and multiply as normal, which is really nice, right? Because we like multiplying fractions. You just multiply the numerators and multiply the denominators. So that gives me 16/15, which is an improper fraction, but that's okay. So let's go through a few more examples. So I have 5 divided by 2/3. So let's go ahead and write 5 as a fraction because that makes me happy. We keep the first fraction the same. We change from division to multiplication, and we flip the second fraction. That's a 3. So I have 5 times 3, which is 15, over 1 times 2, which is 2. Let's try this again. I keep the first fraction the same. I change from division to multiplication, which is represented with an X or a dot. I would start using a dot because we're going to use X as a variable, and I don't want us to get confused. So 7/3 times, and then we flip the second fraction, 8/2. So 7 times 8 is 56, and 2 times 3 is 6. And we could simplify this, right? No. Yes, we can, right? Because this fraction wasn't simplified to begin with. 8/2, that could have been 4/1, so they both have a factor of 2. So I'm going to have 3 over 56 divided by 2. Is that 28? We're going to go with 28. Like I said, it's early. Let's do a couple more examples with negative. Remember, when I multiply a negative and a positive, the answer is negative. Well, when I divide a negative by a positive, the answer is also negative. So I have to keep the first fraction the same, change from division to multiplication, and flip the second fraction. That gives me 3 times 9, which is negative 27, because I've got a negative up front, and 5 times 4, which is 20. And then I check to see if I can simplify this fraction any further, but I cannot. Here I have 2 negatives. Remember, 2 negatives make a positive, but I'll put that at the end. So I keep the first fraction the same. I change from division to multiplication, and I flip the second fraction. So negative 9 over 1 becomes negative 1/9. 2 negatives make a positive. I have 3 over 18. This is not fully simplified because both have a factor of 3, because I have 3 over 3 times 2. That's 18 fully factored. So that's going to simplify to 1/6. In order to multiply mixed fractions, I want you to change them from a mixed to an improper number and then multiply. Okay, so if I have 2 3/5 times 5 1/3, I'm going to go ahead and change these to improper fractions. So 2 3/5 becomes 2 times 5, because to switch from mixed to improper, I multiply my whole by the denominator, I add that to my numerator, and I put it all over my original denominator. So that's going to become 13/5. Same thing for 5 1/3. I take 5 times 3 plus 1, so my whole part times my denominator plus 1 over my original denominator. That's going to give me 16/3. So then I go ahead and I would multiply 13 over 5 times 16 over 3. And then make sure you simplify. The same thing holds true for division. Let's go ahead and convert these to improper fractions. So I would take 4 times 3 plus 2 over 3 divided by 1 times 6 plus 1 over 6. That gives me 4 times 3, which is 12, plus 2 is 14/3, divided by 7/6. Then you divide as normal.